Welcome, friends, to this series of Learning Google Cloud Platform. In the last lesson, we created a VM template and we specified a custom web server inside the startup script so that whenever a VM will be created with that template, Apache web server will be installed with it and a custom web page will be created automatically. If you haven't watched that video, you can watch that video. We are providing the link to that video in description. Now, in this lecture, we will learn what an instance group is and how many kinds there are. We will also learn what are the features and use cases of the instance group. Are you excited to have this experienced? I am sure you will be delighted to have this learning. If you have not yet subscribed to this channel, please do it now. This will help you to watch when new videos will be available. Also, please hit the notification button so that you can get notified too. So, let's get started. An instance group is a collection of virtual machine instances that you can manage as a single entity. Compute Engine offers two kinds of VM instance groups, managed and unmanaged. Managed instance groups, or MIGs, let you operate apps on multiple identical VMs. You can make your workload scalable and highly available by taking advantage of automated MIG services, including auto-scaling, auto-healing, regional deployment, and automatic updating. Unmanaged instance groups let you load balance across a fleet of VMs that you manage yourself. Use a managed instance groups or MIGs when you are having stateless serving workloads, such as a website front-end, or you have stateless batch, high-performance, or high-throughput compute workloads, such as image processing from a queue, or you have stateful applications, such as databases, legacy applications, and long-running batch computations with checkpointing. On the other hand, unmanaged instance groups can contain heterogeneous instances that you can arbitrarily add and remove from the group. Unmanaged instance groups do not offer auto-scaling, auto-healing, rolling update support, multi-zone support, or the use of instance templates and are not a good fit for deploying highly available and scalable workloads. Use unmanaged instance groups if you need to apply load balancing to groups of heterogeneous instances, or if you need to manage the instances yourself. In a nutshell, if you're a great magician having a wizard stick in your hand, you may go for unmanaged instances. Okay, kidding aside, in the next couple of slides, we will discuss only managed instance groups and its features. Managed instance groups are the identical VMs created using a VM instance template. The group of VM instances managed as a single entity. VMs can span within a zone or within a region, but they cannot span across regions. MIG can be stateful or stateless. You build stateless MIG for highly available and scalable stateless workloads, where disks and IP addresses are recreated from scratch on horizontal scaling, auto-healing, auto-updating, and VM recreation. On the other hand, you build stateless MIG for stateful workloads where disks, IP addresses, and/or metadata are preserved on VM recreate operations. Stateful workloads include applications with stateful data or configurations such as databases, legacy monolith applications, and long-running batch computations with checkpointing. With stateful MIG, you can improve the uptime and resiliency of such stateful applications with auto-healing, automatic recovery of failed workloads, multi-zone deployments, and automated rolling updates. You cannot have auto-scaling for a stateful MIG. Auto-scale needs to create or delete VM instances on demand basis, and preserving instance-specific metadata or IP address does not make any sense for stateful MIG. Hence, auto-scaling is a sole feature of stateless MIG. You can create two types of MIG like zonal or regional. A zonal MIG, which deploys instances to a single zone. A regional MIG, which deploys instances to multiple zones across the same region. Both types offer all of the advantages of MIG. Regional MIG add higher availability by spreading application load across multiple zones, which protects your workload against zonal failure, and regional MIG offer more capacity. By default, you can create up to 2,000 VMs in a regional MIG and 1,000 VMs in a zonal MIG. This slide shows you how you can create an instance group. In the upcoming sessions, we will provide demonstrations to show how instance groups can be created and how the different configurations work. But, well, you can find in this slide how we can go to the GCP web console to find the compute section in the left panel. And from there, we have to select the compute engine and then instance groups from that section. Once you go to the instance group, you will need to choose either stateful or stateless MIG and have to proceed accordingly. In the right-hand side of the screen, you can find the form that you need to fill in order to create the instance group. Managed instance groups maintain high availability of your applications by proactively keeping your instances available. MIG automatically repairs failed instances by recreating them. You might also want to repair instances when an application freezes, crashes, or runs out of memory. Application-based auto-healing improves application availability by relying on a health checking signal that detects application-specific issues such as freezing, crashing, or overloading. If a health check determines that an application has failed on a VM, the group automatically recreates that VM instance. You need to make sure that the health check should have write access to access the VM over correct ports. If you configured an auto-healing policy but you did not configure or misconfigure the firewall rule that lets the health check probes reach your application, then your VMs appear unhealthy and the MIG continuously tries to recreate them. You can specify how MIG updates during VM instance repair. If you keep the same instance configuration, it recreates the VM with the same instance template. If you mention to update the instance configuration, it applies the latest instance template and per instance configuration when recreating the VM. Another important feature of MIG is autoscaling. When you define an autoscaling policy for your group, you specify one or more signals that the autoscaler uses to scale the group. When you set multiple signals in a policy, the autoscaler calculates the recommended number of VMs for each signal and sets your group's recommended size to the largest number. The following sections provide an overview of signals based on target utilization metrics and signals based on schedules. You can autoscale based on one or more of the following target utilization metrics that reflect the load of the instance group: average CPU utilization, HTTP load balancing serving capacity, cloud monitoring metrics. The autoscaler continuously collects usage information based on the selected utilization metric, compares actual utilization to your desired target utilization, and uses this information to determine whether the group needs to remove instances or scale in or add instances or scale out. For CPU-based autoscaling, you can use predictive autoscaling to predict future capacity needs based on historical load. Predictive autoscaling improves availability by monitoring daily and weekly load patterns and scaling out ahead of anticipated demand. You can use schedule-based autoscaling to allocate capacity for anticipated loads. You can have up to 128 scaling schedules per instance group. For each scaling schedule, specify the capacity, which is the minimum required VM instances, and the schedule, which includes start time, duration, and recurrence, for example, once, daily, weekly, or monthly. Each scaling schedule is active from its start time and for the configured duration. During this time, autoscaler scales the group to have at least as many instances as defined by the scaling schedule. Schedule-based autoscaling lets you improve the availability of your workloads by scheduling capacity ahead of anticipated load. You can schedule a required number of virtual machine instances for recurring load patterns as well as one-off events. Use scaling schedules if your workload takes a long time to initialize and you want to scale out in advance of anticipated load spikes. However, note, you cannot schedule autoscaling while you are creating MIG. After you create this instance group, you can edit it to create a scaling schedule. MIG lets you create a standby pool of resources to stop or pause a number of VMs. Standby pool is formed by stopped and suspended pools of VMs. All stopped VMs become a part of the stopped pool, and all suspended VMs become part of the suspended pool. If you configured autoscaling in a MIG, after you suspend or stop a VM, the MIG immediately creates new VMs to maintain the recommended size of the MIG. You can suspend or stop VMs in a MIG to pause your application and resume it when needed, according to your computation, working hours, peak time, and budget constraints. You can keep the results of your current computations on persistent disks or, in the case of suspended VMs, in memory. For example, you might want to suspend or stop the VMs in a MIG in a few cases. For example, you have heavy workloads during weekdays and want to suspend VMs on weekends to save on costs. Another use case, if you have a testing environment that is needed during implementation changes and you want to stop it when you are not actively developing. Also, the standby pool is useful to accelerate MIG scale-out. You can keep a standby pool of pre-initialized VMs ready to start when the MIG resizes up. Instead of creating new VMs and waiting for your app to initialize and become ready to run, the MIG starts or resumes VMs from the standby pool. In such cases, the VM initialization is completed in advance, not in a critical moment of increased load. Note, you can even keep 0 number of VMs in the standby pool. In that case, there would be no VM in standby and the pool concept would not work. The standby policy defines the behavior of the standby pool, the mode in which the MIG uses suspended and stopped VMs. This can be manual or scale-out pool mode. In manual mode, you have full control over which VMs are stopped and suspended, and the MIG manual mode is the default mode of standby pool. In scale-out pool mode, the MIG uses the VMs from the standby pools to accelerate the scale-out by resuming or starting them. Then, the MIG automatically replenishes the standby pool with new VMs to maintain the target sizes. To make sure that your VM is initialized correctly, specify the initial delay in the standby policy. The initial delay is the time that VMs wait before stopping or suspending after they are created. This gives your initialization script the time to complete. Thank you, friends, for watching this video. We from the Learning Light team congratulate you to complete this learning. In this lecture, we have learned what instance group is and how many kinds of instance groups are there. We have also learned what are the different features of that and the benefits of using instance groups. In the next lecture, we will continue to learn a few more things on instance groups. But that will be more focused on release management and how we can do that using instance groups. In upcoming lectures, we will see some demo where we will play with instance groups in the GCP web console. Wish you all the best and good luck. Before leaving here, please do not forget to like this video and subscribe to this channel. We worked a lot to present you with such a thing. So, please encourage us by putting your comments in the comments section. If you have any doubt, please leave your concerns and we will reply with our best efforts. Have a nice day and see you in the next lecture.